to thank Anil to have me as a speaker in this course. What I'm going to do is that I'm going to talk about keratoconus, the basic diagnostics, and a little of the overview. I'm not going too much into any too crowded slides, but it's more of a case-based presentation whereby I'll be showing you some maps, and things will be pretty clear with this case-based approach. I have no financial disclosures to make in any matter that I am presenting. When I was sitting for this presentation and I was thinking about how to go about this, what really struck me at the outset was something which I have penned down here. Keratoconus is a refractive continuum ranging from seemingly normal to unquestionably abnormal corneas. So this is the basic philosophy. There could be cases who appear very, very normal, but they still have problems and symptoms, and it is up to us to pick up that subtle keratoconus. And on the other extreme, you might have a very, very frank keratoconus who's staring at you. And then there, the diagnosis is not really very important, but then how you manage and how you go about every case is that it helps us to pick up the more subtle keratoconus signs. And it's also of imperative, it's very, very imperative to know this, because any surgeon who's going to go into laser vision because of irregular aberrations that set in the eye. The various aberrations that are seen are principally the vertical coma, spherical aberration, and the trefoil. This is how a coma looks and impacts the vision. It looks like a comet. Let's come to this case scenario. This is a 17-year-old female student who came to us with just a complaint of headache on and off and unsatisfactory vision. Her uncorrected visual acuity, mind you, uncorrected visual acuity is 6/6, both eyes. However, the refraction was quite funny. It revealed some scissoring reflexes, and the refraction had very high splinters. We went ahead with something called as the eye tracing, which is a very, very robust kind of apparameter based on the ray tracing technology. And you can see that on the topography map here on the right side, you can see that there are a lot of elevation here. You can see that there's a lot of steepening here, and this is kind of vision she has. This is the ultimate vision. Look at it. So quantity-wise, this patient has 6 vision. However, there are so many aberrations which is degrading the quality of vision, and this explains her symptoms. Let's come to some prime cases and the diagnostic criteria. This particular patient, when we subjected to the elevation-based topography, which is the oculizer, you can see that the elevation maps, which I'll come into, it shows a frank keratoconus. The pachymetry is also very thin, and you can see a frank keratoconus with high values here. So she is definitely a case of frank keratoconus. Her pachy values are very low, and even the keratometric values are around 48, 49 here. So when it comes to the topographic diagnosis, what's important is you understand the topography machine that you have, and there are various systems, placebo-based and elevation-based topographies, and many topographic keratoconus indices that we'll just touch up. And this is the age-old placebo disc keratometers, and they quickly give you that there is definitely something abnormal here. They are not very regularly placed Myers. So at a glance you can make out that there is definitely something wrong here. And they show you the anterior surface curvatures of the cornea, which are very high here. And you can see that these keratometric values are 63.5, so there is definitely a slightly inferior paracentral cone. And they give you a variety of indices. The classical rapid criteria have been inferior steepening, more than 47.2 diopters, inferior superior difference of more than 1.4 diopters, and skewing of the radial axis of more than 20 degrees. So when you have a classical bow tie appearance, if the major axis of the two skewing is more than 20 degrees, these have been Ravenowitz criteria. And then there are a variety of these keratoconic indices, which are per se, they give you a level of keratoconus directly. Most of the topographic machines today have incorporated keratoconus detection system, so they give you even the level of keratoconus like KC2, keratoconus S-type, keratoconus 3, advanced keratoconus. And when you look at the progression on the same machine, these indices will change, their values will change, and you know that the keratoconus is actually progressing. Coming on to the more sophisticated elevation-based topographies, I'm not going to go into the too specific, but roughly it is just elevation-based topography, principally meaning that it compares the anterior and the posterior surfaces of the cornea to a best fit sphere for that particular cornea. And if the elevations are too high, you know that those particular points are elevated and therefore they are steep as well. So anything which is green is the reference, meaning the sea level. Anything beyond that is depicted in hot colors, and anything lesser than that is the depressive points are cooled in color, that is they are in the shades of blue. So the primary elevation-based topography which came in was the OPSCAN and later the OPSCAN 2. So this is what it depicts the quad map. This is the anterior surface of the cornea, the posterior surface of the cornea, the anterior and the posterior floats. This is the keratometric map which gives you the keratometry values, and this is the pachymetric map which gives you the point-to-point localization and the point-to-point data of the pachymetry. And then you have these various data, the numerical data, which gives you the simulated K value, astigmatism, and the 3 mm and the 5 mm zone. So these are divided into various zones. So the 3 mm and 5 mm zone irregularity is also given, and then certain additional numericals. So roughly for these, when the OPSCAN came in vogue, we did have some criteria which says that anything more than the irregularity here in the 3 mm zone, more than about 6 diopters and 5 mm of 6.5 diopters was taken as markers of keratoconus. And obviously the anterior floats and posterior float elevations of more than 30 and 50 microns above the best fit sphere were taken as the criteria for keratoconus. However, what I want to say is that not one particular criteria is going to be important. It is going to be the correlation of various criteria. How many red flags or how many pointers you have in that particular patient, and are they correlating? We came to another more sophisticated system in the form of Scheimpflug imaging, where you have a Scheimpflug camera, which is a rotating camera incorporated into this. It obviously gives a lot of actual data points on the cornea, so you get much more data from to extrapolate from, and therefore this system becomes more reliable than other systems. This is again roughly the same one map which shows you the anterior and the posterior floats here, the keratometric map here, and the pachymetric map here. Let us go through some cases which will make it amply clear. So, can I have the lights down, please? So, this is one particular patient who is who has this. Right now, you can see that the keratometric maps are very steep. You can see that the values are around 52.5. Look at the anterior surface and posterior surface of this particular patient. There are elevated points here which are up to plus 18, which is more than 10, and here about plus 53. So this is a very high posterior elevation, and they all are correlating. You can see that this particular hot spot here, and the pachy, and the thinnest pachy here is 518. Now 518, ideally this is not a very bad pachy. It could be a normal pachy, so to say. But in the context of these particular values, all things are correlating, and this patient does have a keratoconus. If you look at something called as the enhanced ectasia or the peri-androgeal ectasia, what it does is that it constructs a different, flatter best fit sphere for that particular cornea, and then compares this to the actual anterior and the posterior floats, and then it takes into account, this is the anterior elevation, the posterior elevation, it takes the difference and gives you another map. And you can see that this center, these values are extremely elevated here. Any differences more than 7 to 10 microns on this particular map are highly suggestive, and they are depicted in red color. And you can see that the particular patient does have keratoconus, which is very frank. Now the other eye, if you can see the other eye of this patient, fairly good normal keratometric values, nothing exceeding more than 47. The anterior float values are definitely less than 10 at all points. However, the posterior float values are borderline, they're about plus 18 on this system, and the posterior float values of around more than 20 are taken to be significant. and he maintains a good packing. The thinnest packing is just 539, which is a very good packing. So this particular eye has to be under observation. This is, as far as now is concerned, this particular patient does not have keratoconus. I just run through other. Do we have time?
Actually, we are running a little short.
We have 2 minutes.
We have 20 seconds.
Okay. So what I should do is that I'll just show you some other cases. Now this is just the other continuum of what I was saying. This is a patient who has got isolated steep corneas. What I mean by that is that on these values you can see that there are very high keratometric values. However, very good packing. The anterior and the posterior floats are extremely normal. There's nothing here. So you just keep this patient under observation. And she is a young patient, around 25-year-old. So this cannot be a keratoconus, though these corneas are very steep. So once in a while you get something like this where we just have steep corneas without evidence of keratoconus. And this is just this will be my last touch-up. This particular patient, there are various maps that you can have on the system. You can have the sagittal maps, the tangential maps. When you're looking at keratoconus or any ectasia, it is these tangential curves or the tangential maps which are of extreme importance, whereby an early keratoconus would be highlighted much more in the tangential map. And in this particular patient of ectasia, if you see this, these are absolutely normal looking map. But when you put this on the tangential curve, you have this particular abnormality here, very high deep values here, which is causing disturbances to the patient. He has very high aberrations because of this epithelial growth, and after washing that off, it gets normalized. What I just wanted to summarize was it's important to look at these patients. What is their refraction? Is there changing refraction? What is their age profile? And it has to be a consolidated interpretation, not in isolation. And monitoring on the same machine, using the same machines is more important. You can't extrapolate one data from one machine to another. I thank you for your kind attention, and along the course, things will be pretty much good. Thank you so much.
Thank you, Dr.